What if I told you that right now, as you're watching this video, there are over 4.28 million robots working in factories around the world? And that's just the beginning. We're living through what experts are calling the ChatGPT moment for robotics, a period where artificial intelligence isn't just helping us write emails or create images, but is literally giving birth to a new generation of machines that can walk, think, and work alongside us. But here's what's really mind-blowing, and what most people don't realize. Some of these robots aren't just made of metal and circuits anymore. Scientists are now creating robots with actual living tissue, fungal networks that can sense their environment, and even cyborg jellyfish that consume 1,000 times less power than traditional underwater drones. Today, we're diving deep into the most comprehensive analysis of how 3 revolutionary types of robots, humanoids, biohybrids, and autonomous systems, are quietly transforming everything from the way we manufacture cars to how surgeons perform operations. And trust me, by the end of this video, you'll understand why some experts believe we could have 300 million humanoid robots working among us by 2050. Let's start with the robots that capture our imagination the most, humanoids. These aren't the clunky, slow-moving machines from 1980s movies. We're talking about sophisticated machines engineered to closely imitate human appearance and behavior, with torsos, arms, legs, and the ability to navigate the same spaces we do. But here's where it gets fascinating. The real breakthrough isn't just in how they look, but in how they learn. Scientists have developed something called fuzzy rule-based imitation learning. Now, I know that sounds complicated, but think of it this way. Instead of programming robots with millions of lines of code, we can now show them what to do, and they create their own interpretable if-then rules. If the human picks up this tool, then I should do this. If the workspace gets cluttered, then I should adapt this way. But there's one company that's taken this learning ability to an almost unbelievable level, and their robot is already working shifts at BMW. We'll reveal which company and what makes their robot so special in just a moment. The game changer has been what researchers call physical AI, essentially, creating sophisticated virtual worlds where robots can practice thousands of scenarios before ever touching the real world. Imagine a robot spending the equivalent of years perfecting its movements in a digital simulation, then stepping into a factory and already knowing exactly what to do. Tesla's Optimus robot is undergoing continuous improvements with Elon Musk's long-term vision of a $20,000 household assistant. But the real story is happening right now on factory floors. Figure AI's robot is already working shifts at BMW, demonstrating incredible versatility for everything from warehouse operations to light assembly, and here's the kicker, it learns on the fly. While it's working, it's getting better at its job. Now, this is where things get really wild. What if I told you that some of the most advanced robots being developed today aren't just inspired by nature, they literally contain living organisms? At Cornell University, researchers have achieved something that sounds like science fiction. They've integrated robots with fungal mycelia, essentially the root networks of mushrooms. These biohybrid machines can sense and respond to their environment using the fungal network's natural electrical signals. Think of it as giving robots a biological nervous system that can adapt to environmental changes in ways that traditional sensors simply can't match. But that's just the beginning. Engineers have successfully transformed moon jellies into living robots by implanting tiny electronic packages. These cyborg jellyfish can be steered with gentle electrical pulses, and here's the incredible part. They consume 10 to 1,000 times less power than conventional underwater drones of similar size. They're so energy efficient that they can operate almost indefinitely, making them perfect for quiet environmental monitoring without disturbing marine ecosystems. There's one biohybrid innovation that could revolutionize medical diagnostics: robots powered by human heart muscle cells that can propel themselves and be controlled wirelessly. But the real breakthrough comes when we combine this with living human skin grafted onto robotic parts. The implications for the future of human-robot interaction are staggering, and we'll explore exactly what this means later in the video. The third pillar of this revolution is autonomous robots machines that can operate without continuous human intervention. These aren't just factory arms following pre-programmed routines. We're talking about AI-driven systems that process vast amounts of sensor data in real time and adapt their behavior to dynamic environments. The numbers tell an incredible story. In 2023 alone, 541,000 industrial robots were installed globally, the second highest year ever. The value of new installations reached $16.5 billion in 2024. But here's what's really impressive. These robots are getting smarter every day. They use machine vision to analyze past task data and refine their movements, becoming more precise and faster over time. Let me paint you a picture of what's happening in manufacturing right now. Imagine a Toyota production line where humanoid robots work alongside human workers, operating continuously without breaks, vacations, or shift changes. In 2023, Toyota reported a 28% increase in production speed and a 42% reduction in quality defects after implementing humanoid robots for interior assembly. The result? $4.7 million in annual savings per production line. But Toyota isn't alone. Samsung Electronics published results showing their humanoid robot deployment achieved 52% faster production cycles and reduced error rates from 1.2% to just 0.08%, while decreasing material waste by 36%. Here's what's really interesting. This isn't just about replacing human workers. Companies are investing an average of 35% more in training programs to upskill existing workers for new roles alongside robots. The goal isn't replacement, it's augmentation. Robots handle the repetitive, dangerous tasks while humans focus on creative problem solving, quality control, and innovation. There's one manufacturing application where robots and humans work so closely together that they literally share physical tasks, handling tools and components as a team. This level of collaboration is creating productivity gains that neither humans nor robots could achieve alone. We'll reveal exactly how this works and why it's the future of manufacturing. The healthcare revolution is perhaps the most profound. The global medical robotics market is projected to grow from $16.6 billion in 2023 to $63.8 billion by 2025-2032. But these aren't just numbers. They represent a fundamental shift in how healthcare is delivered. Over 2.6 million procedures were performed with Intuitive Surgical's robots in 2024 alone, a 17% increase from 2023. But the real story is in the details. Surgical robots are expanding beyond traditional hospitals into ambulatory surgery centers for same-day procedures. A 7-year-old boy was recently treated with the Versius surgical robotic system for a kidney condition with the goal of quicker recovery and less pain. Remember those biohybrid robots with human heart muscle cells? Researchers are developing swimming biobots by culturing human heart muscle cells and neuron cells onto 3D printed soft scaffolds. These systems can propel themselves through muscle contractions and be controlled via wireless signals. Imagine tiny, self-powered robots that could navigate through your bloodstream to deliver targeted treatments or perform diagnostics at the cellular level. But it's not just about surgery. Hospitals are adopting service robots for cleaning, disinfection, and supply delivery, allowing nurses and doctors to focus on what they do best, caring for patients. Sales of medical robots, including rehabilitation robots, surged by 128% in 2023. This is where the story gets complicated. The same technologies that make robots incredibly useful for civilian applications, advanced perception, decision-making, and autonomy, are precisely what make them potentially powerful as weapons. The U.S. Border Patrol extensively utilizes drones equipped with high-quality cameras and thermal sensors for real-time tracking. Ground-based robotic patrols can navigate all terrains and detect chemical, biological, radiological, and nuclear threats. The Department of Homeland Security is even testing robotic dogs at the southern border for surveillance and officer protection. But here's the ethical dilemma that keeps experts awake at night. Can autonomous weapons distinguish between combatants and civilians as mandated by international law? Who bears responsibility if an AI-powered weapon causes inadvertent harm? These aren't theoretical questions. They're urgent issues that need answers as this technology rapidly advances. The future of human-robot collaboration goes beyond simple cooperation. In advanced manufacturing settings, robots and humans now engage in co-manipulation, literally sharing physical tasks, handling tools and components together. The highest level is full cooperation, where both robot and human engage in joint tasks, each contributing their unique expertise. This isn't science fiction, it's happening right now in factories around the world. But the service industry is where we might see the most dramatic changes. Singapore has deployed robotic traffic police for urban traffic management. The global agricultural robot market is projected to exceed $5 billion by 2032, with systems performing automated seeding, fertilization, pesticide spraying, and harvesting. Why is this happening now? The answer lies in demographics. As global populations age and labor forces shrink in many regions, robots become not just an option, but a necessity to maintain productivity and service levels. Here's something that might surprise you. The biggest challenge in robotics isn't making robots stronger or faster. It's making them understand us, and more importantly, making us comfortable working with them. Recent breakthroughs in AI-driven communication are changing everything. Natural language processing allows robots to understand voice commands and provide context-aware responses. Computer vision enables them to recognize and interpret gestures and facial expressions. Some AI-powered robots, like RIA, can even provide human-like emotional reactions for training purposes. Imagine medical students practicing difficult conversations with robot patients that respond emotionally just like real humans would. But there's a fascinating paradox at work here. The closer robots get to human-like capabilities and appearance, the higher our expectations become. When they fail to meet these elevated expectations, it can actually make us trust them less. Scientists call this the paradox of anthropomorphism. The challenge extends beyond just technical development. We're dealing with psychological and sociological factors that require a careful balance between human-like design and transparent communication of robot limitations. Consider this: robots still struggle with the nuances of human language, including informal speech, accents, and situation-specific contexts. They can analyze your facial expressions and body language, but cultural variations in emotional expression remain a significant challenge. Safety technologies like end-of-arm safeguard systems create invisible boundaries around robot tools, ensuring they stop if a human gets too close. But the real safety challenge is robots accurately predicting and responding to unpredictable human behavior. We're witnessing what experts call a geopolitical scramble for AI and robotics dominance. The US AI Action Plan explicitly aims to beat China in this high-stakes technological competition. This includes streamlining permitting, investing in data centers, and promoting the export of American AI technology. But here's the tension. The same openness and cross-border collaboration that drives innovation also creates security risks. Countries are implementing export controls and investment restrictions. The US has measures to prohibit certain outbound investments into entities in countries of concern, particularly those involved in advanced semiconductors, quantum information technologies, and AI systems. The EU AI Act stands as the world's first comprehensive legal framework on AI, adopting a risk-based approach with categories ranging from minimal risk to unacceptable risk. The OECD AI principles provide guidance built on 5 core values: non-discrimination and equality, freedom, dignity, autonomy of individuals, privacy and data protection, diversity, fairness, social justice, and internationally recognized labor rights. But here's the challenge: creating agile regulatory frameworks that can keep pace with technological advancements without stifling innovation. The technology is evolving faster than our ability to regulate it. Despite all these breakthroughs, there's a critical bottleneck that threatens to limit the full potential of robotics. Scientists call it the Valley of Death, the funding gap between basic research and commercialization. Only about 10% of new ventures manage to survive the first 3 to 5 years after launch. Academic curricula often become outdated quickly, focusing on isolated programming languages without sufficient regard for real-world industrial applications. Students graduate unprepared for the demands of modern industry, and academics often lack comprehensive information about the regulatory, quality, and socioeconomic factors critical for commercial success. Here's the crucial question everyone's asking: will robots take our jobs? The answer is more nuanced than a simple yes or no. The data shows that companies implementing humanoid robots report average labor cost reductions of 22 to 28% within the first year. But here's what's equally important: these same companies are increasing their training investments by an average of 35% to upskill existing workers for new roles. The successful integration of robotics isn't about replacement, it's about augmentation. Robots handle monotonous or hazardous tasks, freeing human workers to focus on more intricate, creative, and innovative responsibilities. This represents a redefinition of productivity that encompasses not just output quantity, but also quality of work, innovation capacity, and overall workforce well-being. Without deliberate and sustained investment in education and training, technological job displacement could lead to significant societal polarization. The potential exists for creating a divide between those whose skills are augmented by robots and those whose jobs are automated away. Federal investments in apprenticeships, on-the-job training, and labor market data modernization are essential to support a more nimble and adaptable workforce. The focus must be on designing solutions that enhance human capabilities rather than solely replacing human capital. Projections suggest that humanoid robots alone could reach 2 million units at work within a decade. But here's the staggering prediction: 300 million humanoid robots could be working among us by 2050. This expansion will be driven primarily by their ability to alleviate labor shortages and address the needs of aging populations. The average return on investment timeline for humanoid robots in manufacturing has already dropped from 5.3 years in 2019 to just 2.8 years today. As the technology continues to improve and costs decrease, we're approaching what experts call the EV moment for humanoids, a period of rapid volume increase similar to what we saw with electric vehicles. But reaching this future isn't guaranteed. Success requires coordinated policy development, robust ethical frameworks, and strategic investments in both technology and human capital. We need regulation by design approaches where legal and ethical considerations are integrated from the initial conceptualization of robotic systems. The global nature of robotics development is complicated by significant differences in national regulations and standards. Varied cultural and societal values regarding robotics and AI create substantial obstacles for global cooperation. We stand at a pivotal moment in human history. The robots are no longer coming, they're here. Over 4.28 million industrial robots are already working in factories worldwide. Humanoid robots are working shifts at BMW. Biohybrid robots are swimming through our oceans, powered by living tissue and consuming a fraction of the energy of traditional machines. Autonomous systems are performing surgery, managing traffic, and defending our borders. The question isn't whether this transformation will continue, it's how we'll shape it. Will we create a future where robots augment human capabilities, making work safer, more creative, and more fulfilling? Or will we stumble into a world where technology creates new forms of inequality and displacement? The trajectory points toward continued rapid growth, with projections of 300 million humanoid robots by 2050. But reaching this future successfully requires something we've never had to coordinate before: a global, multi-stakeholder approach that prioritizes ethical development, fosters international cooperation, and invests in massive societal adaptation. The robot revolution isn't just about the machines, it's about us, how we adapt, how we learn, and how we choose to work alongside our new artificial colleagues. The future is being written right now, in factories, hospitals, laboratories, and policy meetings around the world. What role will you play in shaping it?